All right, looks like we've got a fair number, so we'll go ahead and get started. Good morning, good afternoon, everyone. My name is Thomas Holt-Ronzi. I'm a senior applications engineer here at Q-SYS, and today we're going to be talking about how to choose the right Q-SYS core and how to design a system with the correct core processor in mind. Um, I think I mentioned it before. If you jumped in and didn't catch this, feel free to throw any questions in the chat, either in the chat or in the Q&A section. I have both up here on the side screen, so if I will be periodically looking over and uh, and uh, and reviewing those and I'll try and answer them in line with the presentation so that we don't get too far away from the topic. But if I don't get to your question, we will have time at the end for Q&A, or just to ask any general Q-SYS questions that might be relevant to core processors. But with that, I'm going to go ahead and get us started. So we've got a few items on the agenda today. We'll start with just a general overview of what a Q-SYS core processor is. We'll talk about different types of system topologies and how to lay out your Q-SYS cores across a large network or a small network, some additional information about networking, and then we'll get into the new Q-SYS cores, both the appliance core 24F and the X-class server cores. And throughout the way, we have a bullet point here for choosing the right core, but throughout the way, the entire presentation, we're going to be following a decision tree that's going to highlight what key questions we want to ask when we're picking out a Q-SYS core. And then we'll take a look at Q-SYS Designer right at the end and just look at a few cool things about Q-SYS Designer and some of the server cores. But first, what is a core processor? So the Q-SYS core processor has been around for well over 10 years now. And when they were first launched, they were primarily a digital signal processor or DSP device, but they do a lot more than that. So we use a network transport protocol that we call QLAN to deliver audio data across the network, video control data, control automation, and multimodal I/O data, as well as connecting up to the cloud. All of that happens through the Q-SYS core processor, which is the heart of the full stack AV platform. I promise there will be a very minimal amount of sales jargon at the front end of this, but the Q-SYS AV platform is comprised of three nodes: the cognitive cloud, which is Q-SYS Reflect. That's managing everything at the cloud layer, making sure that you can monitor it anywhere in the world. The intelligent platform OS is Q-SYS OS. That is the control architecture, that single operating system that is managing all of the data inside of your AV system. And then multimodal I/O. That's anything that connects to Q-SYS, whether it's native Q-SYS peripherals, those Q-SYS products that you see in that hexagon up at the top. That's Dante, AES67, SMPTE 2110 audio, physical analog audio, all of that's video endpoints, cameras, control data from occupancy sensors. That's all under that umbrella of multimodal I/O, and all three of those represent the Q-SYS AV platform. We also have Q-SYS Open, so that's our industry standard protocols. I mentioned AES67 and Dante, as well as our tools that we use, things like MediaCast and Shift, fall under this Q-SYS Open umbrella. And then our partnerships with LG, Sennheiser, Shure, large list of partners that we integrate directly into Q-SYS, either through plugins, native integrations, or scripts that you can write. And we try our best to support all of these at a very deep level. But the first question we have to ask when we're designing a system is, what is the scale? So when I say scale, I'm talking about, what type of system are we looking at? Is it just a small meeting room? that top image, everybody's in a conference room, little huddle space where we don't have a lot of AV that needs to be controlled. So maybe it's a smaller processor, one single room that's being controlled independently. That medium is going to be that middle branch. That's, things like lecture halls, large classrooms, lounge areas, small bars, sports, esports kind of things, will typically fall into that medium category. And then our large category, that is controlling an entire campus, an airport, stadiums. We fit into all three of these verticals, but how you set up your Q-SYS system for each one of these is going to differ potentially greatly. Some of them it's a little bit less different. So let's look at, specifically with the small and medium, and as they relate to a large system. Most of the time that small core is not on its own. That small system is not on its own. It's bundled with a bunch of other small systems, or, a small medium mix. And we need to distribute core processing across a network. So there's two ways to generally classify this topology. One is centralized. So you have a single core processor that lives on the network and it manages all of your AV spaces at once. Maybe it's an X10 that lives in a server rack somewhere, and then every single room on your network just has peripherals. It makes, smaller locations easy to manage because you have less points of failure in the room and just one designer file to go look at. This does come with a few caveats. If you want to add more data, more information, or more rooms to that system, then you have to manage the single Q-SYS file. And that brings us to the other type of system, a distributed topology. So that is every room on the network gets a core processor with its own bespoke I/O, and each one of those is managed independently. Maybe you're using Q-SYS Reflect to remote into those systems to update designs and manage them, but you can do that very easily and very agilely because you don't have to take down the entire network. But because you spread everything out more, it requires a little more resource investment. You got to buy more cores. You have to go out to those physical locations that you need to swap hardware out, as opposed to landing everything in a single rack room. And just to highlight these more visually, here's an example of a centralized topology. So we have a single core processor and a network switch landed in a rack somewhere, not in each of these individual rooms. And then in the meeting room, we've got some I/O, audio and control endpoints like QIO boxes or NV, video encoders and decoders, and cameras. Lobby is the same. We've got network loudspeakers, amplifier, maybe in a closet. Auditorium's got a bunch of I/O. You get the idea. All of that is controlled from one central location with the I/O living where it needs to be. So it's a very modular design language versus the distributed topology where this is those same four spaces, but each one has its own core processor, its own network switch, and its own physical I/O at that location. Now, this comes with an advantage that the network stack is much simpler because each individual system is managed independently, and you're just, maybe you have each core processor tagged to a VLAN that exists on all four of them so they can talk to each other and send information like background music back and forth, or that reception desk has to page everyone. One of the other things you can do with this is when that audio that doesn't need to be synchronized, or video that doesn't need to be, that's overflowing out of the auditorium, you can use non-clocked transmit methods to send that AV back and forth. Things like core-to-core streaming, system link, wide area network transmitter allow you to get data from one core to another without having to have all of this in the same design. And to facilitate that, every Q-SYS core has at least two network interfaces. Um, LAN A is where all of your Q-SYS, all of your local QLAN information is going to be. So that's, you have a camera that's going to hook up to the LAN A network. And then LAN B will typically be used for an auxiliary LAN to connect to your campus network, to connect to something like an MTR. But we can manage these independently. They're fully segmented, so there's no way for a device on LAN A to talk to a device that's connected on LAN B on the same core, unless Q-SYS is talking to that device. Gives you the power to segment your network a little more intelligently. And then we also have on this LAN B network in this image, you can actually see a static route that we've added there. So that 1.101 network can actually talk to devices on that 49.0 network by forcing a static route, including that subnet inside of what Q-SYS is looking at. So we can actually manage that network more intelligently. And then on top of that, Core Manager allows you to actually decide what services and what traffic is going on each network interface. So some of them you don't want to turn off, like designer communications. In this image is actually grayed out because if you turn that off, then Q-SYS Designer itself can't talk to the core. But if you don't want, LAN B to have access to the remote control protocol, QRC, then you can turn that off on LAN B and on all the auxes. Or maybe you want to leverage QRWC, our new API. You can turn that on just one interface, but we give you control of how that data is managed across the network and allows you to separate that information. So that's network topology. A small room, you're probably not worried so much about this. You're going to put a core in there, you're going to put a network switch in there, and you're going to be done with it. On a large network, all of this comes into play as you have to make sure to manage things like PTP clocking and VLAN tagging and how multicast is playing with the network. So all that out of the way, let's talk about Q-SYS cores. So this image shows almost all of the Q-SYS cores we have. It doesn't show the NV32, but it shows the 8 Flex, the Nano, the 24, as well as all of our new X-class servers. So we did refresh the entire server class line over the past year, as well as the Core 24F has been released to give you guys more options when selecting for what processor and how much processing you need on the system. So back to my decision tree. So like I said, we classify these as small, medium, and large. With small and medium, we immediately jump into what I/O are we using? Are you connecting analog microphones or loudspeakers? Do you need GPIO? What type of USB connection? That I/O is going to become really important. With large systems, typically we move straight to that centralized topology, and we just jump into how much processing you need to determine which server core. So for the small and medium rooms, let's talk about the Core 24F. So this is our most flexible core processor. It's really meant to give you a wide set of capabilities. It's the Swiss Army knife of Q-SYS cores. Lots of I/O on the back, lots of processing under the hood. Solved most small to medium rooms can be run on a Core 24. Lots of network I/O. This was meant to be the successor to the Core 110. So the Core 110 has been discontinued. It was introduced in 2015. It's over 10 years old at this point. So we decided it was time to retire it, let it go, enjoy its retirement, go to the Bahamas. And we've brought out the Core 24. So Core 24 has the same I/O on the back of it. So 24 channels of onboard I/O, has a bank of flex channels. So you can decide if those flex channels are inputs or outputs per channel. It has twice as much processing as the Core 110, 50% more, well, not 50%, but close to 50% more I/O capability, um, double the Dante capacity, 50% more AEC processing, more peripherals, more media channels, more everything. It's really meant to be a proper refresh of our flexible I/O core. Um, Again, just more customization, more capabilities, um, fits in a 1U rack. This is an example of, this is a medium space. So we have our Core 24, we've got network switch, we've got a network amplifier, a whole NV system here, decoders, encoders, um, lots of ceiling speakers, lots of microphones to talk to, GPIO, cameras. All of this can be run just off of a single Core 24. And on the back of this, many of you will remember that we took away the GPIO and the OLED panel on the Core 110 during COVID. We have brought those back with the Core 24. So now we have 8 mic line inputs, 8 flex channels, 8 line outputs, and 8 GP in and 8 GP out, as well as the 12-volt DC rail. So you have lots of ways to control that system, shade control, maybe a contact closure for a fire alarm system, talking to an occupancy sensor, whatever you need to do there, you can get at that with the Core 24. We also increased the number of network ports on the back of it, so now it has 4 network ports, as well as you refresh the USB connection, so now it has USB-C on the back, and the OLED panel has come back as well. So that's the small to medium. If you need less than that, we also have the Core Nano and the Core 8 Flex. The Core Nano has no analog audio, but it still has RS-232 as well as GPIO and USB connect capability on the back. The Core 8 Flex has the same things, but we also add a bank of 8 flex channels. So small rooms that maybe just need one microphone at the podium, and a little bit of control can leverage those. Now for those large systems, the X-class processors, these replace the 510, the 610, the 5200. Those are, that's specifically what these replace, with complete off-the-shelf server-based solutions, enterprise hardware, full network I/O. These are meant for centralized systems. I don't expect that there will be a lot of these that are just running one room. You're usually running one room and a lot of overflow audio out to like a lobby. So if it's running one room, it's going to be a very large auditorium. So 256 I/O for the X10, 64 channels of AEC, 128 Dante channels. One big change with the X10 and the X20R is that so the Core 610 had similar specifications for the base model and the scale model. We've decided to break that out to 2 different products. So neither of these have scaling licenses. They're fully capable out of the box, which means that you just buy the core and deploy it. X20R has 384 channels, 128 channels of AEC. The big thing here, that little R on the back, you're going to see that again on the next page. So the X20R and the X50R have redundant hot swappable power supplies. So what that means is they use Dell's modular power supply technology, and they have 2 power supplies in there. Both connect to 120 volt. If one fails, the system will run off of the other one, and then they're hot swappable, so you can just pull it out, service it without taking the system down. The X20, we also reduce the depth of the appliance core. One of the main complaints with the Core 610 was that it was very deep, and that just made it difficult for network AV racks. And then finally, the X50R. So the X50R replaces the Core 5200. It also is a significant horsepower upgrade. So the 5200 was your catch-all for anything larger than what the X20 could handle. The X50 is meant to run stadiums. 4,000 channels of audio when using the two 10 gig SFP ports, 512 audio, 512 by 512 network audio if you are just using the two 1 gig copper ports. 512 channels of Dante, 256 AEC channels. Again, those redundant hot swappable power supplies. This is meant to be the biggest server. It's meant to handle, an entire airport. The X20R and the X50R, most of these designs, if you're designing for this core, you are also looking at redundancy. These are critical applications where the system can't go down. So you're also looking at a second one so that if this ever goes down, you flip over to the backup core and the system keeps running. And these network-only cores, again, no physical I/O on them besides the network connections. They're meant to leverage our modular I/O and make sure that you have the I/O where you physically need it in the system. And then they have a ton of headroom so that if you need to add more to these systems, you can without having to leverage a ton of extra cores or trying to break out your design in weird ways. So looking at the X10 and a room that the X10 would fit right at home with. So this is a divisible multi-purpose space. So maybe there's a cafe at one end, an all hands space at the other, and in the middle there's two divisible walls and a conference room, boardroom type space. The X10, we have a ton of network video here. So every room's got an encoder and a decoder, or multiple decoders so that we can bring things like room PCs in. Multiple MXA 920s in the ceiling so that you get ceiling audio everywhere. QIO ML4s at the podiums at either end for lectern audio. Tons of GPIO in the space. But this is an example where there's not a whole lot in the rack, lots elsewhere in the space. And then the X20 takes that idea and just amplifies it. So 8 meeting rooms, each with their own network microphones, NV21s, and SPAQ for network amplifier to drive ceiling speakers. That's a typical of 8 meeting rooms. So we've got 8 of that same meeting room. We could have 16 to 20 of those, no problem. We have our paging station at the reception desk. We also have our lobby with some signage player that we're talking to through Q-SYS, network amplifiers, NV21, IR to talk to the TV, and then our auditorium is also leveraging our PL series line arrays, CXQ amplifiers, tons of power there. How do we, when we're looking at this, all of those X-class processors, it's like, okay, well, one of those could probably drive all 3 of those scenarios. The X20 would be the easiest one to choose from. We do have a one sheet for all of this. So this screen is that. There is so Jonathan asked if we have a copy of this presentation. I believe it is online in the on-demand section of the Q-SYS webinars page on our website. So if you go to qsys.com, find the resources tab at the top, find webinars. In the on-demand section, I believe we do have a link to all of this. You can also take a screenshot of the presentation if you want to have this handy as just an image. But yeah, looking at those, looking at the IO. So that first number, total network IO channels, we keep using that on the specifications. What that means is QLAN and AES67 audio. So that is clocked audio on the core. So if you're grabbing, a QLAN, a QIO box that has an ML4i, for example, that consumes 4 input channels. So that would count on your network IO streams because we're streaming that audio from the QIO box to that core. So Dante does not count in this because Dante uses the software Dante capabilities of the core. But AES counts in that. And any AES-based transport. So AEC channels, like Core 24 has 24 AEC channels. All of the small cores have 8 channels of AEC. So the Core Nano, the 8 Flex, and the NV32. The Core Nano and 8 Flex do have a scaling license still. That increases AEC, it increases media and WAN channels, increases the number of peripherals, and that is not shown on here, but we'll talk about it right at the end. So we have been on this sheet for a moment, so I'm going to go and go to the next slide. So with the small and medium cores, just to jump back into our decision tree. So this question of, are you connecting any microphones and loudspeakers? So no, we can look at, again, what's the size of the room? If it's a small room, then we use a Core Nano. If it's a medium or larger space, then we have the Core X10. If the answer is yes, I have analog microphones and loudspeakers, then we look at, for the small room, you have the Core 8 Flex. For that medium space, we have the Core 24. And here is that entire decision tree broken out. So this is most of the time when you're talking with an applications engineer and you send us a drawing and say, hey, how would I spec this out for Q-SYS? A lot of the times what I'm looking at is I'm looking at the size of the room, in square footage. Usually I'll just figure that out so that I can determine speaker coverage, microphone coverage. Once I've determined that and how you want to connect to the system, that's when I walk through, what IO do I have, and then what type of space I'm looking at. And that's when we make the determination of, Core 24 versus 8 Flex versus Nano. X10 and larger starts to get more complicated. You look at how much control processing you're planning on using. Are you planning on leveraging Q-SYS Vision Suite? If so, then Core 24 or higher becomes a requirement. How many UCIs is not something I typically jump into too much, unless there's a big scope for, I want 70 touch panels. Then maybe, even though there's a limited amount of IO, if I have a large touch panel count, then I will look towards the Core 24 or the X10. As long as I'm under that 96 peripheral count, I usually don't need the X10. So, and I mentioned Q-SYS control. Just another mention that the Q-SYS control engine is built into Q-SYS Designer, and you don't have to, we got rid of the scripting and UCI deployment licenses, so those come bundled with the cores now. So you can just open up Q-SYS Designer, start scripting, start building UCIs, and not worrying about separate tools or anything like that. And this is just the opportunity to mention that we had gotten rid of those licenses. We do sometimes get rid of the licenses. And with that, we also consolidated the Core Nano and 8 Flex scaling licenses. So previously you had 2, the commercial and the collaboration bundles. We've gotten rid of those, and now it is the consolidated scaling license. It doubles network channel capacity, doubles AEC count, gives you more peripherals, again, this is meant to supercharge the Core Nano and the 8 Flex for systems where the 24 was overkill, is overkill, um, and but or you have a space constraint where you need to get closer to that Core 24 without the footprint of a full 1RU core. We've also changed how the multi-track playback license works. So that is now stackable. So it comes in 32 by 32 increments, and you can just purchase as many of those to get up to whatever the maximum for that core is. With the server cores, the X20R and the X50R, I mentioned the redundant power supplies. Those do require some additional configuration to get running. So if you're using the X20R or the X50R, there is a property inside of Q-SYS Designer that is redundant power. You have to set that to yes. And then inside of the server core itself, these are Dell-based cores. So they use a Dell system called ID Rack, which is how it's a BIOS configuration tool for the server. And there's a hot spare configuration needs to be disabled so that it's not or has to be enabled for failover. There's a few configurations. We have a guide in our at support.qsys.com in our FAQs. We have a guide for configuring ID Rack for hot swap mode. And then once that's configured, you can go into Q-SYS Designer and actually read the data off the power supplies independently. So you can do things like log those to the event log, or send that information up to Q-SYS Reflect. There's a whole bunch of things you can do inside of Q-SYS Designer to monitor the server core status. Things like redundant, which core is active, which networks are active. So if you're using network LAN A and B on the server cores as redundant network connections, you can monitor the status of those. You can see which core is currently running, how long it's been up, a variety of things. And then inside of Q-SYS Designer itself, I'll actually jump over to a running design, to a design that we have for this webinar. So in the inventory section over here on the left, I have a lot of IO here. I have tons of amplifiers. I've got IO 110s. I've got IO 8 flexes, nanos, flex 4As, GPIO, tons of NV32s and touch panels. This is all running on a single core. I believe this is a X20R. Yeah. So this on a single X20R. And you would think that with all of that, with all of these amplifiers in the system, tons of audio players, tons of scripting, that this would be we'd be pushing this core to its limits. There are 256 peripherals in this system. We're maxed out on audio recorders. We're using 50% of the audio player count. So we need 128 multi-track playback licenses. But this is only consuming 17% of the available signal processing according to check design. So this tool, this is called check design. It's built into Q-SYS Designer. If you go to File, Check Design, what it will do is it will compile the system for you without sending it to a core, and then it will return a system report on that as far as estimated bandwidth. It'll check how many of each type of processing you're using. So if you have category 1 processing is things like EQ and audio routing. Category 2 processing is dynamic processing, things like AEC, voice activity detection, how many NMT1s you're using. All of that gets measured here. And then it just gives you an estimation. It's not a full evaluation of the design, but it gets you much closer to understanding how close you are to the limit. And with that, we've kind of covered everything. So I want to, this is meant to be a Kickstarter for deciding what core processor you want to use. So I want to make sure to leave time for questions from you guys. Make sure to ask questions. What if you have a specific project that you're, without getting into too many details, what kind of core would I choose for this scenario? A lot of the questions about what core you want can be answered just by walking through this one sheet of capabilities for each core and kind of doing a checklist of, okay, I have this number of transport channels from my peripherals, I have this many ceiling microphones, so I have this many AEC channels. Do I need USB audio, external audio? Do I need I have 70 peripherals, that kind of thing. Media, I need this much media drive capability to store, pre-recorded messages for my symphony hall. All of that kind of information can usually be derived straight from this sheet, and just kind of building out your decision tree of, even further than just analog microphones and stuff. Do I need, how many cameras do I need? What am I doing with those cameras? I mentioned Vision Suite. One of the questions in your decision tree should be, am I planning to use Q-SYS Vision Suite? Either if the answer is yes, am I using legacy, or when Vision Suite Designer is released, then you'll also add, am I using legacy or am I using Vision Suite Designer? Because Vision Suite Designer will require the Core 24F or higher. So that's just some of the things that we look at for choosing a processor. There will be a recording that will come out if you want to view another version of this, there is one in the on-demand section of the webinars page. So you can always go back and review a recording to see this delivered. Luke asked, for Core 110s that were manufactured before UCI deployment and scripting engine licenses were offered, is it possible to enable 8x8 software Dante with a generic upgrade license? So Luke, I will answer your question. The answer is yes. It is a little complicated, but I want to provide context for everybody. So the Core 110 was around for so long. It was introduced in 2015. It's officially end of life now, but it hasn't been fully discontinued because we still have some in stock. The Core 110 was built before licenses and before software Dante existed. Those were introduced somewhere around version 7. I know Q-SYS Designer 7.2 is when the license structure was put in place. If you have a core that does not have software Dante, you can reach out to your area manager, and we can work on, if you just need an 8x8 license, we can work with you on that. It does have to be purchased. But one of the other things we'll want to check is some of those. There is a small number of Core 110s that were built before 2017. that do not have the capability to go to designer 10.0 or newer. Um, so we would want to check the serial number on that and make sure that it is that it's that we it doesn't you may be getting left behind for a Core 110 that is that old. If you have a Core 110 that didn't have those that is was purchased after those licenses existed, but you never purchased the licenses, I have good news for you. So you can go to support.qsys.com, type in Core 110 license into the search bar, and because we've gotten rid of the scripting and UCI deployment licenses, we are giving those away. There is an EID on the support page that will give you those licenses. So you can go back and add those back into older systems that didn't have those capabilities, and you can add those capabilities back in. Daniel asked, is there a way to estimate if running a large number of scripts will be possible on a smaller core? What are the factors that influence this capability? That is an excellent question, Daniel. The answer is no. There is not a good way to estimate script usage on a core currently. It is something that we do want to look at, but there's a complicated reason for that I don't necessarily want to get into. The way that Lua scripting happens on the core is that all of those Lua scripts run in what we call and run in one thread. So because all of that Lua processing happens on the core in one giant thread, we don't have a way to estimate individual usage for individual scripts aside from looking at how much memory is reserved for that script. So big things that influence the capability for script usage is memory. If you're using a Core 24, you're going to have a fair amount of headroom. Lua is a very lightweight language that doesn't require a lot of reserved memory. The garbage collector also comes by at a fairly irregular interval. It's every time memory doubles on a Lua script, the reserved memory doubles, it'll run the garbage collector. There isn't a way to estimate this, but generally speaking, if you have a script that is doing a lot of processing on a small core, I tend to avoid doing a ton of really, really big scripting. I tend to look for just simple plugins that do, controlled displays. Maybe I write an auto switching script. Yeah, it's difficult to estimate and difficult to determine on a core by core basis how many scripts you can run because we don't separate that out from other types of processing. As far as how much memory each core has, I believe the Core 24 has 16 gigabytes of memory. I don't have that information off the top of my head. But reach out to your applications engineer, and I believe we can get that information for you. It doesn't. Yes. Yeah. Add so. Luke asked for feature requests to add AI vibe coding within Q-SYS Designer. Right now, the only AI accelerated technology that we utilize is Sear Vision, is the Vision Suite Legacy, which is run on Sear Vision OS, which uses AI computer vision to model a person standing in space. And Vision Suite Designer uses AI acceleration using the VSA 100 to do a similar thing with data fusion for audio and video from Q-SYS cameras and microphones. we're very careful about how we want to implement AI into Q-SYS Designer. So stay tuned. That's all I can say for that. And yeah, with more more technology capabilities is always something we're looking to add into the software ecosystem for Q-SYS. All right, we got a bit more time here, so keep those questions rolling in. Trying to think of what other information I'm just trying to info dump to you guys as much as possible um about Q-SYS and TA TAA approved. So we do have a list on our website. And let me see if you know what? We'll just see if I can pull that up. So Zach asked if we have a list of TAA approved devices. And the answer is we do. Do it. So we'll go ahead here. So if you go to qsys.com/TAA, you will actually get brought to this page that covers our solutions, government and judicial page. And this is where we cover, we give, some additional information for our government and judicial end users. But we do have a PDF of our TAA compliant products. So this is just a list of everything we make that is TAA compliant. And scrolling down, all of the cores do have TAA compliant SKUs. So easy answer is yes, we're TAA compliant. The Nano, the X10, X20R, X50R, Core 24, 8 Flex. There are variants there is a variant of the Core 110 that is TAA compliant. There's everything in here, everything in our product portfolio that is TAA compliant is listed here. So, as well as, as some additional information, when it was last updated. So yes, we do have a TAA compliance list. Yes, as many of our products as we can make them are TAA compliant. All right, continuing. Let's see what other questions. Really, we have no other questions. I've answered every single question you have about Q-SYS. That's incredible. I didn't think we could do that in under an hour. I guess I'll open it up more as like, does anybody have any questions that are less specifically about the Q-SYS core processors? Oh, the MTR component. So, yeah, Irvin, I'll answer this one. So, the MTR component. Let me get Q-SYS Designer back up, and if it'll hide that page for me. So I'm going to open a new schematic page and we'll bring in. So we have, I'll add the discontinue list. So previously we had a component in the Q-SYS Designer inventory called the MTR component, or Microsoft Teams Rooms PC. And what this was for was for interacting with an installer that comes with Q-SYS Designer called Q-SYS Control for Microsoft Teams Rooms. And when you installed this on your computer, it creates it, or on the Microsoft Teams compute device, it creates a link to transmit the second page experience to the Microsoft Teams compute. And that turns on that button in the bottom corner that shows room controls. When you open that up, it links back to a user interface, a UCI that you create inside of Designer. This block has been discontinued. The reason for that is starting in 10. I believe 10.2. We introduced Q-SYS Connect. So Q-SYS Connect is Q-SYS Connect is a new installer that packages in place of the Control for MTR application. When you open that installer up, it asks, are you installing for Microsoft or for Zoom? If you install for Zoom, there's a whole different set of tools that it builds in the compute. If you install for Microsoft Teams, it installs the connections for the second page experience. And then the Q-SYS Connect component links back to that. And the reason we changed out and deprecated the MTR component in favor of Q-SYS Connect is that what Q-SYS Connect does is it turns on Q-SYS Discovery Protocol inside of the compute device. Q-SYS Discovery Protocol is the multicast protocol that we use on all Q-SYS components for device discovery. So it sends out a multicast packet from every peripheral and every core saying, I'm a Q-SYS device. This is my host name. This is my IP address. This is the design I'm currently running. This is how we track keep alive. This is how we do firmware updating. So we've leveraged that inside of the Microsoft and Zoom compute devices now so that we can do automatic device discovery. So it'll discover the room. It'll tell you if it's a Zoom or Teams room. It'll tell you if it's currently awake. We can also send a wake up message to the MTR. It will tell you the IP address, the host name, what UCI it's currently running. And you can actually control that visibility as well. If you are using it in Zoom mode, there is an additional block in the Q-SYS Connect inventory called the Virtual UC Controller. And this connects to a touch panel that is in MediaCast display mode to allow you to take a Q-SYS touch panel and use it as a native Zoom controller. There's a few extra steps to do this, but it allows you to bring that Zoom application layer onto Q-SYS Glass and use a Q-SYS touch panel as a native Zoom controller. So this works on any Windows-based Zoom compute. So Austin and Irvin, I'm kind of answering your questions as one now. So to use Q-SYS Connect with Microsoft or Zoom, you do have to have a Windows-based compute. So it won't work on a Mac currently, and it does not work on Android devices currently. That's due to we need to spin up the QDP protocol service, and we're designed around Windows-based applications currently. So as far as utilizing Q-SYS Connect onto the touch panel with a third-party UC device, that's Windows-based computes only. I don't believe, unless you're referring to third-party touch panels, which I don't believe we support that currently. The way you would leverage this with Zoom is you would bring the Zoom UI onto the Q-SYS Glass, and then you would use the Zoom controls marketplace, the Zoom app marketplace, to bring in your room controls into the Zoom environment. Zach asked, you have a lot of advanced tools for troubleshooting issues. Is there plans for possible training? So we do have some manufacturer specific tools that we leverage for if you're having an issue with Q-SYS, you contact Q-SYS support and we'll ask you for the Q-SYS logs. And we leverage those to do some diagnostic under the hood. There are a variety of support tools. We are working to try and make some of those more customer facing. And when that happens, there will be training for those. But right now, the most of the diagnostic that you'll do as an integrator is through the event log and through Core Manager and through Q-SYS Designer. Irvin asked, any tricks on how to resize a UCI for different panels? Or is there any dynamic design options? So that's a great question. One thing that I do is when I'm building a UCI, I typically, unless I know that it's always going to live on a TSC 70 or a TSC 101, or hopefully I don't have to build something too complex on a 5-inch panel. If I think it's going to be generalized, I design for, instead of using a specific target touch panel, I'll design for a 16:9 or a 16:10 panel. That helps with the resizing. When you change target devices, Q-SYS will attempt to resize for you, but placement of, that's obviously, it's not going to be able to perfectly place everything in relative space because you're changing scale, you're changing DPI, you're also changing vertical window size. If you go from a TSC 70 to a TSC 101, the aspect ratio is a little bit different. So what I tend to do is I tend to use CSS for my element sizing on the buttons. And then for the actual layout itself, I tend to simplify structures. So I'll use a single layer to manage my background elements for each page. That way I can go and I'm just changing out what objects live on that page. And then that does help because I have less objects to go and resize and scale. We are working on making better tools for dynamic design. So stay tuned on that. And then Austin, I know there were a couple bugs with 10.2 and 10.3. So I would recommend trying on 10.4. And if you're still having issues, contact our support team. Again, support.qsys.com. You create a case, either online or on the phone. You can reach out to us and we'll usually get back within, as far as I'm aware, the wait time for our support team on the phone is in single digit minutes. They're extremely good at their job. If you create a case online, then we can respond to it via email. It's always same day. And we'll make sure to get you squared away. But with that, we are at the top of the hour, and I am out of questions. So I'm going to go ahead and close it down, guys. Thank you very, very much for joining. I appreciate all of you guys coming and spending the hour with me. There should be an email going out with a copy of the recording. And if you have, obviously, reach out to your local Q-SYS area manager or Q-SYS applications engineer if you have any questions. Thank you guys very much and have a wonderful rest of your day.